Hello everyone, welcome back to another video where we're going to be solving more Leetcode. We're going to be solving a medium problem today, medium difficulty, product of array except self. So let's get into it. So given an integer array nums, return an array output where output at I is the product of all the elements of nums except nums at I. Each part is guaranteed to fit a 32-bit integer. And then follow up, could you solve an O of n time without using the division operation? So basically division is not allowed and we have to solve this in O of n time. So let's run through the example here. So we have input nums and the output here. So as you can see, it takes it. So then let's write this out here. So we have 1, 2, 4, and 6. This is our, so you have to get output at I is equal to product of all numbers in the array except at that position. So let's say we're at 1. This has to be the product of everything except 1, everything else in the array. So what is that? 2, 4, and 6. 2 times 4 is 8. 8 times 6 is 48. So that means this element right here has to be 48 now. Become 48. Output has to be 48. Now let's go to 2 here. 2, you have to get the product of everything except 2. So that's 1, 4, and 6. 4 times 6, 24. 24 times 1, still 24. So then 24, as you can see the output here, 48 and 24. Now you get to 4. You have to find the product of everything in the array except 4 and put it in that 4 position. 1, 2, and 6. 2 times 6, 12. 12 times 1, 12. So now 12. Now you finally get to 6. Now you just gotta get the product of everything except 6. 1, 2, and 4. 2 times 4, 8 times 1, 8. So this is our final expected output. So obviously, if we had division, this would just be really easy. You could just get the product of all of these input numbers and then just divide by each number, and then you'd put that in output array. That's how it would be really easy. So that's why it forbids division, to give us more of a challenge. So the core trick here is prefix and postfix here. Prefix and postfix products. So that is a trick here that you guys need to know. So we want the products of all elements to the left of I, products of all elements left to I, multiplied by all the products of all the elements to the right of I. Prefix being left, postfix being right. And we call these the prefix and postfix products. So if you multiply that, we would get our output, our desired output. So let's run an example here real quick. So let's say for nums, 1, 2, 4, 6. So then at index 0, so we're at index 0 now, the first element, there's nothing to the left of 1. We're doing the prefix first. So everything, the product of everything to the left of I. There's nothing to the left of 1. So you just assign default value 1. And then now at index 1, 2, there's only one number to the right of 2. So you just have 1 again. And now let's say you're at index 2. Index 2 is 4. We're at 4 now. the product of everything before to the left of 4 is 1 times 2, which would be 2. 1 times 2, which equals 2. And then now we have index 3. We're at index 3, which is the last index. 6, everything to the left of 6, the product 1 times 2 times 4, which is also 8. So now that would just be 2 times 4 times 1, which equals 8. So now, obviously, now these are our prefix products. Now let me erase this. Let's go to our postfix products here. Let me just rewrite this. So now we would store those prefix products in a array. We'll store that in our results array. So right now our results array, output array, is 1, 1, 2, 8. This is our prefix products from the input array. Now it's time for our postfix. So now our postfix will be going backwards, remember, because prefix is everything to the left, postfix is everything to the right. So the best way to do that is to go reverse from right to left. So now we would start at the last index, index 3. So at index 3, there's nothing to the right of index 3. So that would just default value. So default value 1. Then 2, we would get, obviously, index value 2 is 4. To the right of that is just 6. So you would just get 6. And then you add value 1. Value 1 would be the 2 here. So what is the product of everything to the right of 2? 4 and 6 here, which would be 24. And then you're at the first element, 1 here. 1, 2 times 4 times 6. 4 times 6, 24, times 2, 48. So now these are our postfix values. So now we have our prefix values here and our postfix values here. All of them are here. So now you multiply the prefix at I times the postfix at I. So, and then you would get your solution. But instead of building 2 arrays, we can compute everything in one result array, as I said here. So obviously have the result first of the prefix, and then when you're getting the postfix, just multiply by the same indexes. So then you would get our answer. So we're saving memory here. But obviously we would need 2 passes. So one forward pass for the prefix and one backwards pass for the postfix. And this keeps the memory at big O of 1 extra space. So now let's start coding this up. So we're here now. So let's initialize the result array. So now our result array here, we want it to be right now consisted of array filled with 1s. And we want the length obviously to be the length of the input array. So we'll create an output array filled with 1s. We'll gradually replace these values with the prefix and postfix products. So why are we using 1 here? Because multiplying by 1 does not change anything. So 1 is perfect. So now let's make the loop for the prefix pass. So let's have our prefix 1 for I and range length nums here. So now let's walk through this slowly. So prefix always stores a product for everything to the left of I, correct? So before using prefix, we assign it to the result at I. So this position here, we'll assign prefix. So then we multiply the prefix by make this multiply and set equal to nums I. So now this will calculate the prefix, give us our prefix values, and put it in the result array. So now our result array will look exactly like this for now. For this example, it will look exactly like this right here. So now that we've done that, now result will hold all the prefix products. Now we have to get the second pass, which is the postfix. So our postfix is to add 1. So now postfix stores products of everything to the right of I. So now we have to go in reverse. So for I in range, obviously we're going reverse, and type range, then nums -1. Okay, so then now we multiply the existing prefix value in the result at I by the postfix value now. So we get the result of I, and remember our result of I for now stores the postfix values from this loop, and then now you want to multiply that by our postfix value. So equals postfix, and then we update the postfix for the next element to the left. So postfix would equal multiply nums at I. So now this, after these two loops run, we should have our result. So the time complexity here is O of n, 2 linear passes, linear time, and the space would be big O of 1. So we only use one array here, one output array. So that is great. So now after these two run, we can just return result, and then we can run this. As you can see, it works. There you go.